Hi, this is Victoria Lasarte, and this is the final presentation for our Info 3406 assignment on behalf of Mackenzie Simpson and myself. Our assignment was based off the question, can recurrence of breast cancer be predicted? This question was developed after looking at a data set from an HTML source. This data set specifically had 286 instances, and each of these instances had 9 attributes and a class attributes. The 9 attributes were age, menopause, tumor size, lymph nodes, nodes capped, degree of malignancy, breast quad, and irradiation. And the class attribute, which our research question was based off of, was recurrence or no recurrence events. We had 2 hypotheses in this experiment. First was the null hypothesis, which stated the recurrence of breast cancer cannot be predicted. On the other hand, the alternative hypothesis stated the recurrence of breast cancer can be predicted. Naturally, there is a 50% chance of accurately predicting a patient's future diagnosis. Therefore, our decision tree should have a greater than 50% chance accuracy in determining whether a patient or not will have a recurrence or will not have recurrence. In order to do this, we broke up our experiment into 3 steps. First was designing an initial decision tree. We did this by initializing the test size to 0.33 or 1/3 of the data. We set the random state variable or the random number generator assigned to 5 in order to make the outcome consistent against all calls. And the following was the result. We got a precision score of 0.73, a recall score of 0.73, and an F1 score of 0.68. After this, we used various decision trees, interchanging the combination of variables, and we used a grid search in order to find the best possible combination of variables, and we found that this occurred when criterion was set equal to entropy, the max depth was at 3, and the splitter equal to random. This gave an F1 score of 0.7, which is again greater than the 50% chance of just randomly guessing if a patient will have a recurrence of breast cancer or not. After doing this, we decided to use McNemar's test as was utilized in one of the weekly labs. And McNemar's test is used to determine when there's a split in the data to see if there's marginal homogeneity. And like we did in the labs, if the test prediction was accurately predicted, we set it equal to 1. And then if it was not predicted or predicted incorrectly, it was set equal to 0. As you can see, this is the following results. After looking at McNemar's test, it was time to see if our decision tree compared better to baseline. The value calculated was 5.93 e to the negative 17th, and since this value is smaller than 0.05, the chance of accurately predicting the correct outcome, our decision tree is a reliable source. Therefore, we can reject the null hypothesis, concluding that the recurrence of breast cancer can be accurately predicted. This is significant as it can help the doctor's treatment and the prognosis in order to better handle a patient's breast cancer.